Good afternoon, all. Welcome back to the online sessions. And in today's session, we're going to start up with a subject called MCC, which is known as Mobile and Cellular Communications. So this MCC is normally comes under the wireless communications. And here we deal with the basic concepts of the cellular communications. So what are the basic concepts of cellular communications? It deals with basic architecture of cellular communication and what are the various benefits or advantages, disadvantages of the wireless communication systems. And next is what are the various limitations also of the wireless communication systems and architecture of the wireless communication system basically in 2G, basically called as GSM communications. So in GSM, what is that? GSM stands for Global System for Mobile Communication. So GSM is basically of 2G technology, comes under 2G technology. And in India, the 2G technology is really a great success. And many people are simply implementing the 2G communications. So nowadays, we are all using the cellular mobiles, or you're using the cell phones. So all these cell phone communication is normally based on the 2G communications, called as done by using a GSM technology. So GSM is purely based on the 2G technology. So now in the today's session, what we do is we try to go with some of the introductory part of these wireless communication systems. Okay, and after we complete with the basic part of wireless communication system, we just touch about the basic architecture of the basic cellular communication system, and after that we just deal some of the basic operation how a call is normally going to get made by a cellular mobile. Okay, in the next classes, we discuss about other concepts such as frequency reuse, channel assignment strategies, and handoff process. Okay, so in today's session, so in the first unit straight away, he is going into the basic cellular system and its operations. So straight away, the syllabus is simply jumping into the now, as we are discussing about like this MCC comes under the wireless communication systems, we deal with this now. What is, first of all, what is the definition of a cellular telephone system? A cellular telephone system is basically responsible for providing what coverage throughout a particular area wirelessly. So that is what the basic responsibility of a cellular communication system or cellular telephone communication system. So a particular area means what? Coverage region or a market. So it has to compulsorily cover a particular area wirelessly in order to provide the communication, in order to provide the communication between one or many devices. Is basically known as the cellular cellular telephone system. Now let us look into the basic example of architecture of a cellular mobile system. Here in this particular diagram, various base stations have been shown. That BS is nothing but known as a base station. So base station 1, base station 2, base station 3. So all these base stations 1, base station 2, base station 3, they are shown like a circle, but it is not like a circular coverage is normally supported by the cellular mobile. It is only for example sake that that particular base station has been shown in the circular region to say that it is covering certain region which has been encompassed by a circle. Okay, encompassed by a circle. Now imagine that here we are going to have base station 1, base station 2, base station 3. Now all these base stations are simply connected to the mobile switching center, are known as mobile telephone switching office. And all these are simply connected to the public switch telephone network, which is going to be purely a wide network. Wide telephone network is going to be the public switched telephone network. So from this, once again, reverse process is normally going to take in place for the receiving mobile station. So for example, let us look into this now. This particular car, this car, inside this car, imagine that there is a driver. This driver is having a cellular mobile. Driver is going to have a mobile phone. Now this driver is going to make a call to some other person in another network. Then what will happen? To the nearest base station, this call will be connected. From this nearest base station, the signal goes to the MSC. From MSC, it goes to the PSTN. From PSTN, again, the nearest MSC of the destination mobile phone. Then reverse process, it will go to the nearest base station of that, then goes to the recipient mobile. So this is how the communication normally going to take place from one mobile to the another mobile, or from a transmitter mobile to the receiving mobile. So nowadays we are all making calls or experiencing the working of the mobile phones. So how these mobile phones are simply working? The mobile phones are simply working by this particular fashion only, which is known as a 2G communication, or 2G technology is being used here, which is known as GSM technology. So in India, we are normally going to have a GSM technology which implements the 2G generation specifications. Okay. So now, what is the link between the mobile and the base station? The link is normally going to be the simply air. Air is going to be the interface between the mobile unit and the base station system, or base station office. Now here, what do you mean by these base stations? Base stations are known as the towers. At our nearer places, we are all seeing the towers nowadays. So many towers. Now let's discuss about the various connections. Okay. Now what is the connection between the mobile unit? This car is going to be called as a mobile unit. This mobile unit is communicating with the base station using wireless media, and the connection between base station and the MSC is going to be a wide media. So we can normally going to use a microwave links or any other landline links like optical fiber, coaxial cable, any wiring methods, transmission lines we are going to use to connect it to the MSCs to have effective communication between the base station and the MSCs. Okay. So next, let us look into the next one. We look into the differences between wireless communication and wired communication. Okay. Now, in the case of wired communication, what happens now? The transfer of information takes place over landline trunk lines made of the optical fiber cables. OF stands for optical fiber cables, or a copper cables, as we discussed, microwave links or satellite links. That means there should be a physical connection or a physical wire in order to communicate between one device to another device in the case of the wired communication. Just like a LAN connection in the computer labs, they are connected by wire. Okay. Similarly, let us look into the wireless communication. The transfer of information now takes place with the help of signals which travel in air as the EM waves, called as electromagnetic waves. So here all the devices all the devices in the network are connected wirelessly in the case of the wireless communication system. Whereas in the case of wired communication, they will be connected with the various types of wires such as optical fibers, copper cables, microwave links, and satellite links. The next difference which we can have is in the wired communication, network configurations are virtually static in the case of the wired communication. What do you mean by the network configurations? That means whether the network is a star topology network, it's going to be a ring topology network, or a bus topology. What type of topology is simply involved, that has to be configured before the communication takes place, and once it is configured, it is going to be static for throughout the entire communication process. These network configurations are going to be normally fixed in the case of the wired communication. And what is the drawback of this wired communication? Distance is basically a constraint for the subscribers. You cannot implement the wired communication systems for very long distances. Now this is what the problem why the wireless communication has come into picture. Now here in the case of wireless communication, network configurations are not static, they are highly dynamic. The network configurations will be changing from time to time based on the availability of the network in the communication system. In the wireless communication system, the network configuration gets rearranged every time a subscriber moves into a different coverage region. So as we are talking about, the network configuration is not going to be static, it is going to be dynamic in the case of the wireless communication systems. The next one is one more problem we normally going to have is when the subscriber changes his residence. What will happen now? Needs reprogramming at the local central office of the subscriber. So at central office of the subscriber, we have to make the changes regarding the particular subscriber. Whereas coming to the wireless, such kind of things are not there in the case of the wireless. Wireless networks must reconfigure themselves for users within small intervals of time to provide roaming and handoff facilities. So continuously the wireless networks are normally going to get reconfigure themselves. whereas in the case of wide it is going to be pre-configured. Next one is the available bandwidth can be increased by installing high capacity cables. So if you use a what is that copper cables, the bandwidth is going to be less. To use more bandwidth, we can implement microwave links, or we can use the optical fiber cables. So using them, the available bandwidth which was there earlier can be increased by installing high capacity cables. Now, whereas that kind of a facility is not there in the case of the wireless communication system. In the case of this wireless communication system, networks are constrained by uh, little RF cellular cables provided for each user. Okay, so that means the problem here is the bandwidth. That means the bandwidth is going to be a limitation here. In the case of wireless networks, wireless networks are constrained by the little RF cellular bandwidths provided for each user. So the bandwidth provided is going to be very less in the case of the wireless communication systems. So now here this particular slide is normally going to show to connect this signal which is coming from one of the user through a different types of the channels. So exchange, different types of exchanges, exchange A, B, C, D, and other central offices we can connect now. That means from one type of signal from one type of configuration can be converted to other type of configurations at the time of transmitting the signal from one type to another type in the case of the local exchange kind of the communication. So this is what a simple local landline telephone network, which is all going to be wide communication. So this wide communication is basically a 1G communication. 1G communication normally involves all the analog communication techniques. That means these are the systems which have been used in the early 80s. In the early 80s in India, people used to have this particular kind of a landline systems, landline telephone systems. So the telephone system normally going to have this kind of a basic architecture. Then what are the advantages and limitations of this particular wireless communication systems? So the wireless communication systems are going to be extremely complex communication systems. And why? And at the same time, what is the advantage? In wireless communication systems, the maintenance is normally going to be zero. There won't be any maintenance cost in the case of the wireless communication system, even though the system is complex. But there is no complexity in the case of maintenance of the communication system. In the case of the wireless communication system, so radio channel is extremely hostile and random in nature. The radio channel which we use to transmit the signals is not going to be always uniform throughout the lifetime of the signal. So therefore it is going to be extremely random in nature. The next limitation is going to be growth in wireless systems leads to increase in base stations. Now what happens is, if at all I want to increase the coverage, if at all I want to increase the coverage capacity, then I have to increase the base stations. Now, extra overhead is required for MSC as the geographical location of the mobile unit changes constantly. Now, what happens is, as the number of mobile units increases, MSCs also should go on increase, because MSCs cannot support infinite number of base stations. As the mobile units are going to increase, base stations should increase. As the base station increases, MSC is also going to increase. So these are the basic limitations. And one more limitation of the wireless networks in terms of the high bit error rates. Usually the wireless communication systems are going to have a bit error rate, more bit error rate. The data which we receive is going to be more erroneous data than the wireless communication systems. So one example is been given here in the case of the point-to-point link communications. Now there is a transmitter here, there is a receiver here, and there is a point-to-point communication is going on here. What happens is, in this scenario, the signal strength may decrease as the signal is going to disperse as it travels greater distance. The signal is going to get dispersed as it travels to longer distance, attenuates as it passes through the matter. Now here, even though there is a vacuum here, but the atmosphere is not going to be uniform throughout this particular free space. So as the atmospheric medium constants are changing here, therefore attenuation is normally going to happen in the signal. Therefore, the signal strength is normally going to decrease, usually in the case of the wireless communication systems. And next problem is going to be the interference from other sources. Radio sources in same frequency band will get interfere very quickly. Therefore, interference effects is going to be more. Okay, and electromagnetic noise is also going to get added with the with the radio wave signals. So, what do you mean by this electromagnetic noise? Usually generated by microwaves or any other electronic gadgets. So all these gadgets are normally going to release some electromagnetic waves. These electromagnetic waves are simply going to get mixed up with the actual signal of this particular transmitter. So by the time it reaches to the receiver, the signal is simply added with some noise, and this receiver is going to receive the signal with a lot of noise. So that's what, because of the interference, noise is normally going to increase. And one more problem it experience is going to be called as multi-path fading. See, there is a transmitter here in this tower. This transmitter is transmitting signal, and an aeroplane is receiving the signals now. Now, what are the various problems we normally encounter in the case of the multi-path propagation? See, this is the direct path which is usually recommended, but signal may not go in this particular fashion all the time. Sometimes signal will simply it reflected from this hill area. Signals are reflecting to from this house, and the same signals are reflected from this house also. So that means signals are simply getting reflected from the objects. So therefore, this electromagnetic, all these are what now? These waves are electromagnetic waves which are transmitted by the transmitter. So these EM waves reflect the of objects, taking many paths of different lengths. So as the signal is taking many different paths, what will happen? It normally going to cause the blurring of the signal at the receiver. So the receiver section should be complex compulsorily in the case of the wireless communication systems. So these are the some of the drawbacks which we can normally going to have. Okay. Then a simple network, if you think about for a first generation wireless network, that means just before we step into the 2G, that is what first generation wireless networks. So what is the exact first generation? First generation networks are going to be simply the wired telephone networks are known as first generation networks. They were there up to 80s. We have first generation networks using which we used to normally have a cellular communication, normally going to have a wide communication. So these first generation networks are going technology are going to be based on analog technology. Now all cellular systems uses the FM called as frequency modulation, and cordless telephones uses a single base station to communicate with a single portable terminal. Now, this is the simple schematic diagram for the communication, which is normally going to be stepping into the 2G. That means end of first generation, beginning of second generation is going to be AMPS network, AMPS technology introduced by the US government. So we normally going to have a mobile user. The mobile user can move to a little distance, and we normally going to have a base station, and base station is connected to the MSC. Okay, now imagine that there is a similar kind of a setup in a reverse order for the receiver. There is a source mobile user, there is a receiving mobile user. Source mobile user want to communicate to the receiving mobile user, same as the present 2G technology. So whatever signals that we are transmitting, whatever signals the mobile user is transmitting, they will be received by the base station. Base station in turn will transmit them to the MSC. This MSC will in turn transmit them to the nearest base station of the receiver, and then finally the base station is going to retransmit the same signal to the receiving mobile. So this is how we normally going to have the communication basically in the beginning of the 2G technology. Okay. Now in this particular scenario, we can normally going to have various types of channels involved. What are the various types of channels which are normally involved here? So whatever signals that are being transmitted by the base station to the mobile user called as the forward voice channels, forward setup channels. So what do you mean by forward transmission? Forward means what? Base station is the uh, you know controlling unit of the mobile station. So based on the controlling unit of the base station, all the mobiles are normally going to operate. So therefore, the signals coming from base station to going towards mobile station known as the forward channels, and reverse, that is from mobile to the base station, is going to be the reverse channels for us. So therefore here in the case of this communication, in the case of say voice communication, two types of signals are normally going to be there. One is going to be the forward voice channel and a forward setup channel. So some setup signals has to be generated before a communication normally going to take place. Okay, after setup signals get set, then the communication is normally going to take place between the mobile user and the base station. Okay, now from base station to the MSCs, how the things are going to be now like. So from base station MAT, they are also going to be the voice circuits. We normally going to have a switched telephone networks used to connect it to the MSCs. Okay, just now, just like we have discussed about the switching network. We have seen here the switching network here. Let us see the switching network once. Yeah. So this is the switching network. So from the mobile station, we normally going to connect it to the many other stations using the switches. Now these switching types are based totally on the types of the networks we normally going to get connected. Well, now how the practical 2G cellular communication system simply looks like. Now see here, earlier I have shown you with the circles. Now here I am showing you with the hexagonal shapes. Now here for a cellular communication system, that the coverage area of the base station, this is the BS is known as a base station. So the coverage area of the base station is normally represented by a hexagon, because hexagon means what, the data loss is going to be very less if you normally going to use the hexagon between the base station and the mobile units. So this car is known as a mobile unit. This car is known as a mobile unit. Okay. Now these base stations, different base stations are normally the base stations which are adjacent to each other are going to use a different frequency bands, and the base stations which are far away, okay, which are far away, that means after this base station, let us suppose if you got another base station here, and the channels, the frequency channels used for this base station and this base station are normally going to be different for us. So that difference in frequency we normally going to be called it as a frequency reuse mechanism. Same set of frequencies are normally going to get used if we know that there won't be any effect of interference between one base station signals to the other base station signals. Therefore we normally employ different same set of frequency bands for different clusters of the for different clusters of the base stations or different groups of the base stations. Now the basic architecture of this 2G network is something going to be like this. So we normally going to have more than one base stations, that is known as our cell phone towers in our nearby places. We're all going to see so many cell phone towers nearby us. Okay, so like that we have seen these base stations now. So all these base stations are simply connected to the MSCs. See, this is one region of base station. This is another region. Imagine that this is Telangana region. Imagine that this is a Andhra Pradesh region. So now this Telangana region base stations are connected to MSC 1, Andhra Pradesh base stations are connected to the MSC 2. Now these two are simply known as a different base stations. Now what will happen now? Whenever the mobile phone is simply roaming inside this Telangana region of the base stations, we will be called as a local charges will be imposed on that particular person. Now whenever he is going to cross one state to another state, now, if at all the base station of the Andhra Pradesh state is going to receive your signals, what will happen now? This particular mobile phone will simply coming into the roaming. So once it comes into roaming means what? Extra charges has to be imposed on this particular mobile phone, whichever is entering into into the zone of the region another region. So that's how we normally going to have this. Now to these MSCs, what will happen? Several other databases, several other networks, several databases are normally connected, such as HLR, VLR, AUC. So this AUC is nothing but the authentication center. VLR is nothing but visitor location register, home location register. So visitor means what? The Andhra Pradesh cell phone, registered cell phone may come into the Telangana. Telangana registered cell phone may go into the Andhra Pradesh. So in that scenario, what will happen now? This visitor location register is normally going to register this particular mobile station in the database for billing purpose. Similarly, home location register, whichever mobile phones are working only in the are operating only in the Telangana region, they will be stored in the home location register. The next one, similarly, you normally going to have an authentication center. Authentication means what? If at all your mobile phone services are not going to have the service such as the roaming service, if roaming service is not there, then authentication center will simply going to has to authenticate about the services. If roaming service is there, it will authenticate. If service is not there, it will simply disconnect the call, because the mobile unit or the mobile user is simply entering into another region of the operation. So this is how basically the working, how the mobile phone is normally going to communicate. Okay, so they say that means what? Say for example, a mobile phone which is in the Telangana region, he is in Telangana region, registered in Telangana region. There is a mobile phone in the Andhra Pradesh region. Now these two are talking to each other by staying in their own local regions. So extra amount will not be charged to the caller, from the caller unit. Okay, that is how we normally there. We are all experiencing nowadays. Okay, now this is how we normally going to have. Then now the two MSCs are normally going to get communicated by using a wide PSTN network. What is PSTN network? Public switched telephone network. That means different MSCs are normally going to get interconnected by using the public switched telephone network. And SS7 is normally used for signaling purpose. Special signaling methods we normally going to be implemented by SS7, because we are always 2G. After 2G, 3G has come. After 3G, 4G has come. After 4G, now presently 5G research is going on. After 5G, definitely 6G is normally going to come into market. So therefore, the special signaling method should go on increase. So the special signaling methods are normally going to get incorporated in this particular layer here. So that is why this extra thing has been provided to support the future coming services that we need to provide to the system. Okay, so after this we have various generations now: first generation, second generation, and third generation. See now, once we come from first generation, what is first generation? Basically, first generation is going to be provide only analog speech. For analog communication only, we use the first generation communication. As I was talking to you, the wide telephone systems which normally going to support only analog communications, analog speech can be transmitted. Now, what about the data rate of transmission of this particular systems? Very low data rate is going to normally support between the mobile unit and the base stations. So until early 90s, the user had to register manually each time he entered into the market. So whoever wanted to use the what is that telephone, wide telephone, he has to register himself in the market. Okay, with the central office. Then only is normally going to have the communication with the wired telephone systems. Now, due to the evolution of this international standard 41 standard allowed different cellular systems to automatically accommodate users who roam into new coverage regions. So this particular, after 1990, many other developments have come, many other evolutions has come in the cellular mobile communication. And in the second generation, we normally going to have, we employ digital modulation techniques and advanced call processing capable and supports advanced call processing techniques. So the example of second generation is going to be GSM in India, more popular, IS-95, IS-136, normally used in US, and personal access communication systems, PACs, and in Europe, digital European cardless telephone systems. Now here what happens is the MSC's burden is downsized by deployment of the base stations. Now, what happens is in the case of the 2G generation, whenever we wanted to increase the capacity of the network, we have to increase the base stations accordingly. So once the base stations increase in base stations is going to be really more than the is simply increasing the cost, then we normally going to incorporate one MSC. So like that, we normally going to have the combination of BSCs and MSCs in order to increase the capacity of the cellular mobile communication system. Now, this second generation normally going to use the digital voice coding techniques and digital modulation techniques. So, digital voice coding techniques. So, various coding techniques are available. So, all these various coding techniques are normally used to normally going to communicate the signal, uh, such as FDMA, CDMA, TDMA. All these are the different coding techniques which we normally going to use in the 2G technology. So unlike this first generation, which is only developed for the voice, 2G has been specifically designed to provide paging applications. So unlike first generation, which is only developed for voice, 2G has been specifically designed to provide paging applications. Paging means what? It is going to be nowadays we are sending SMSs. So to send SMSs at the time of 1G, first generation 1G networks, we used to have pages. So using pages, we can able to transmit the text messages. Okay, text messages cannot be transmitted by using the mobile phone in those days. And next one is going to be the handoff process. Now, how the signals from one base station is simply getting connected to the another base station when the mobile is moving from the region of one base station to another base station is simply called as a handoff. We discuss about handoff when we really deal with the uh, first unit basic operations. Okay. So the mobile units also perform several other functions, such as what are the functions our mobile unit is doing? It is going to function such as received power reporting. It is normally going to report how much power it has received to the base station, and it's going to normally adjacent base station scanning. It performs base station scanning. The nearest base station has to be scanned by the mobile station. Wherever it finds the strength, more strength, it will be connected to that particular base station. So data encoding and data encryption can be done by the mobile units. So these are the various operations which is normally performed on the mobile unit. Then next comes into the third generation. Third generation means what? Increasing the capacity of the data transmission. So if at all you want to transmit more amount of data other than voice and just a message, then 3G is normally going to come into picture. So once after 3G comes into effect, internet has come into the picture now. Okay, so that means what? Mainly developed to provide single set of standards that can meet wide range of wireless applications. Wide range means what? What is the range? Voice I should transmit, data I should transmit, and I should transmit different types of data also. So to transmit different types of data, such as multimedia files, such as the computer data files I want to send, and video files I want to send, voice files I want to send. Okay, so different types of voice data files I want to send, all of them I can do by using the 3G technology. Okay. So packet radio communication is used to provide high speed and reliable information transfer. So the more popular one is going to be packet radio communication systems. So we transmit data in terms of various packets, just like computer to computer communication. How the two computers are normally going to communicate? They communicate in terms of packets. Here also, in the case of the 3G communication, the data is normally going to get transmitted by packets. So the example of such systems is going to be 3G PCs, broadband ISDN networks, okay, so on and so forth. So these are the various types of the networks which we normally going to have. So we study in depth about various generations of these technologies in the last unit. In the first unit, in the next class, what we do now, we study about the communication between the two mobile stations, and the process of handoff and frequency reuse mechanisms in the next class. Till then, thank you very much for the today's session.